Hello, this is Professor Ubaswai. Today we will learn how to solve radical equations. So let's get started. Here's the principle. It's called principle of powers. When a equals b, you can raise them to the same exponent power. Okay, pretty easy. If 2 is 2, I can raise them into second power, and that will get 4 equals 4. All right, so that makes sense. Let me give you some steps. And the first step is, when you're asked to solve radical equations, isolate the radical term using algebra. Second, use the principle of powers that I just showed you, raising the powers, to eliminate the radical and solve for x. If you don't get rid of all the radicals, you go and you isolate the radical one more time and do the second step. Use the principle of powers to eliminate the radical again. So you may have to do that twice. But what is important is you have to check your answer either way. Because in these radical equations, sometimes you'll get an answer that's called an extraneous solution. And it's not going to work when you plug it back in, and it's not going to work. All right, so I'll show you some examples. Now, let's do the first one. The question is solve radical x equals 5. Using the principle of powers, what you can do, you can raise them to second power because that will get rid of that radical in here. So you're going to end up with x equals 25. And let's check. Is radical 25. When you check, put a question mark on top of the equal, so that kind of tells you you're checking. Is radical 25 the same as 5 in the original equation? Yes, it is. Always have that step. How about this one? I'm going to raise this into a power. You're going to have 4. X minus 1 equals 25. Okay? And then you're going to have x minus 1 equals 25 over 4. X equals 1 plus 25 over 4, which is the same as 4 plus 25 over 4, which is 29 over 4. And now you're going to solve it. So let's see if that works. Check. 2 radical 29 over 4 minus 1. Is that the same as 5? 29 over 4 minus 4 over 4, that's 25 over 4. When you take the square root, you're going to get 2. 25 over 2. These two will go. And square root of 25 is 5. Check. Okay? All right. Now, a word of caution. What is this? Understand the difference between this problem and that problem. When you're doing this problem, you raise them into squares and you get x equals 25. When you have this problem, you take square root of both sides. From here, you're going to get absolute value of x, and from here, you're going to get radical 5. And from here, you're going to end up, with x equals positive rad 5 and x equals negative rad 5. Know the difference. Here you got one answer, here you got 2. All right, don't mix them up. Okay, what happens when I have this situation? I have cube root of x equals 5. Now what I do, I raise them to the third power. What does that give me? X equals 5 to the third power, that is 125. check. Is cube root of 125 5? Looks like it. Now, how do I do this problem? Remember, the first step was isolate the radical. Okay, at 4, you're going to have 4th power, 3x plus 1 equals 3. And what are you supposed to do? Raise them to the 4th power. That will give me 3x plus 1 equals 3 to the 4th power is 81. Subtract 1. 3x equals 80. X equals 8 over 3. Are you done? No, you're not. Check. So let's look at it. Is 4th root of 3 times, instead of x, put 80 over 3 plus 1 minus 4 the same as negative 1? I don't know. This one will give me 80 plus 1, 81, minus 4 is that negative 1. 81 is, 4th root of 81 is 3, minus 4. It looks like negative 1. Check. It did work. Okay, so what did you learn? Higher powers, 4th root, 4th power, 5th root, 5th power. Okay, I think I can handle that. Let's look at some weird cases. Somebody's asking you, can you solve this one? Square root of x equals negative 5. If I go and blindly square this, uh-oh, you are in a whole lot of hurt. Now let's think. Can a square root be a negative number? No real solution. That's not possible. How about another even root? Can an even root be equal to negative 1? Guess what? No real solution. So do not go blindly do this problem. How about odd roots? Can that work? Yes, it can. An odd root can be a negative number, so you can actually go ahead and do this problem. Okay? So x equals 333. That is negative 27. And you can check, is cube root of negative 27 negative 3? Yes, it is. All right, know the difference. Even roots, no real solution. Odd roots, and let's see if it works for these guys. And if you take the 7th power, you'll get x equals negative 1. Does that work? 7th root of negative 1 is negative 1. It does. So be careful with these two cases. More complex problems. Okay, so let's go do those. What do I need to do? I need to go and I need to isolate the radical. Let's do that. 5 minus x equals x minus 3. I just moved 3 over. Square it. Pay attention. 5 minus x equals, FOIL it, x squared minus 6x plus 9. How do I solve something like that? I move everything to the right. Plus x minus 5 plus x minus 5. That will give me 0 here. X squared plus x is negative 5x minus 5, that's 4. Can I solve that? Looks like it. This is a product sum method. Here we go, negative 1, negative 4. So that gives me x minus 1, x minus 4. So if you don't know how to factor fast, go and watch my video about factoring. And that's equals 0. That means x equals 1, x equals 4. Am I done? No. Check. So I'm going to check 1. So let's look at that. 3 plus 5 minus 1 is that one. 3 plus 4 minus 1, 5 minus 1 is 4, that's 2. Is that 1? It looks like that's not the case. 3 plus 2 is not 1. Uh-oh, x equals 1 did not work. Let's try the other one. X equals 4. 3 plus 5 minus 4 equals, is that 4? 3 plus 5 minus 4, that's 1. That did work. Guess what happened? This x equals 1 is an extraneous solution. So it's a solution that's a no solution. So the final answer is x equals 4. That's it. Not x equals 1. So make sure you understand that. Okay. Let's look at this problem. Okay, let's isolate. I thought I did this problem, but I guess I didn't. Let's isolate x, one of the radicals. Let's square it. You're going to have an x. And here you're going to have 1 minus 2 x minus 9 plus x minus 9. All right, look what happened. Okay, and this will give me 1 minus 9, that's negative 8. Negative 2 x minus 9 equals 0. Let's move this to the left. Look what happened. You'll have 8 equals negative 2 x minus 9. Now, I did not get rid of all the radicals. Isolate the radical again. So what do you have? X minus 9 equals 8 divided by negative 2, negative 4. Before I do squaring and stuff, I remember one thing that my teacher told me. Can a radical equal a negative number? The answer is no. No real solution. Does it make sense? So remember, in the previous example, I ended up solving for the equation, and then I ended up with 2, and one of them did not work. In this case, I didn't even have any work. Okay? How about this one? Is this possible? I'm going to isolate one of them, and let's see what happens. Let's isolate that and square. It's already isolated, so I don't have to do a whole lot of work. So I'm going to have a 4x minus 3, because square with square root is itself. And let's FOIL that out. First one squared, plus twice first and last, which is that. So try to get into doing these guys a little fast. Plus last one squared, which is this. Okay, now I'm trying to isolate this guy and move everything to the left. I have 4x minus 3 equals 2x, which is this. Negative 5 plus 4, that's negative 1, plus 4 rad 2x minus 5. Move everything to the left. Let's see what I get. 4 minus 2, that's 2. Negative 3 plus 1, that's negative 2. And I have 4, 2x minus 5. Do you get it up until now? These guys are just kind of like big numbers. So what I'm going to do, I'm going to divide everything by 2 because I can see it right away. That's going to give me x minus 1 equals 2 rad 2x minus 5. All right, I isolated the radical. I can actually go and move that 2, but I'm going to get a fraction. I just don't want to deal with that. So what you need to do is just go and square both sides. You're going to get x minus 1 squared equals square 2, which is 4, square that, which is 2x minus 5. Let's FOIL that in. That is 8x minus 20. Let's open that up. X squared minus 2x plus 1. Excuse me. 8x minus 20. Move that over. So move that over. So what am I going to get? Let's move down. Here I am right now. I have x squared minus 10x plus 21. And let's do it with product sum. Negative 3, negative 7. Let's factor x minus 3, x minus 7. Set each factor to 0. I got 2. Okay, well, let's go and plug them in to the original equation. Here's my original equation. 4x minus 3 equals 2. 2x minus 5. So I'm going to check now 3 and 7. Alright, so let's check 3. And let's check 7. Okay, when I check 3, so you have 4 times 3, that's 12, minus 3, that's 9. Is that equal to 2 plus, that is 6 minus 5, that's 1. So that'll give me 3. That's 2 plus 1, that's 3. X equals 3 checked out. So let me do that. I was not even showing you, just rewrite it and write it. Okay, here you go. So I checked. Here's my original equation. I just put in 3 for x and see it worked, and it did work. Let's do the same thing with that one. Okay, 4 times 7 minus 3. Is that the same as 2 plus 2 times 7 minus 5? I don't know. Let's look at it. This is 28 minus 3. That's 25. Is that the same as 2 plus? That's 14 minus 5. That's 9. So the square root of 25, that's 5. Is that the same as 2 plus square root of 9 is 3? It looks like it. Now, do you remember what we did? We did one example where nothing worked. The other one, only half of it worked. And in this one, you have 2 answers. They checked out. X equals 3. Here's the final answer. X equals 3 or x equals 7. Okay? So both of them did work. And this is the end of this section.